Okay, thirst. The other side of fluid balance, of course, like we can do all we can to reduce loss, but in the end, you're going to have to put more fluid in. You know, conservation of matter, it's a physics thing. All right, so how do we manage our fluid intake so that our osmolarity stays within the normal range? Well, essentially, that is our thirst mechanism. So anything that causes the release of ADH will also trigger a powerful thirst drive, a drive to increase water intake, right? So we know that ADH will do that. Plasma osmolarity all by itself, though, will also trigger thirst. So even if your ADH system is broken, an increase in plasma osmolarity still will trigger the thirst system. Okay, so like, what if we didn't have this system? That's what this graph is showing. So along the x-axis is sodium intake, right? So increasing sodium intake each day. And on this axis is our plasma sodium concentration. Yes, ma'am.
On the chart, it says that a decrease in plasma osmolarity decreases thirst, but then in the writing it says a decrease will increase water intake.
A increase in plasma osmolarity increases thirst. A small decrease in osmolarity of the plasmas. Oh, you're right. This should be an increase. Sorry. Small increase in osmolarity of the plasma still results in water intake. Yes, behavior. So thirst is a second system. Good. I need to make a note of that to change that. What slide number is that? Do you even know?
14.
Huh?
14.
14. Okay. Thank you for pointing that out. Oh, I was talking about this. Okay, so as sodium intake increases, how does our plasma osmolarity change? Well, in us normal people with an intact ADH and thirst system, this is us, red line. We do see a small increase in osmolarity at extremes of salt intake, but mostly over this very wide range of sodium intakes, we have a very stable plasma osmolarity. If we took out the posterior pituitary, we would not have that. That's the blue line, right? So the thirst system is directly related to maintaining our plasma osmolarity in a very narrow range. And you see this in your patients too. Like it is relatively uncommon to see a person up walking around with an osmolarity that's really screwed up, right? People who have a messed up osmolarity usually have significant clinical symptoms, you know, so it isn't a subtle thing at all.